As we have seen, cocaine and amphetamine act by increasing the amount of dopamine available at the synapse. Scientists have wondered, what are the brain regions that are affected by these drugs? One region has caught their attention. It is located in the middle of the brain, and it is called the reward pathway. The neurons in this region communicate with each other using dopamine. Drugs of abuse, including cocaine and amphetamines, affect synaptic transmission in these regions. Neurons in this region serve an important function in our daily lives. They are responsible for our everyday pleasures and drives. They drive us to do the things that we need to do to survive as a species, like finding food, shelter, or sexual partners, or taking care of our young. Interestingly, dopamine is used by neurons in the reward pathway during any situation that would induce pleasure, like finding food when you are hungry. A similar, but stronger dopamine release occurs when the brain is exposed to drugs like cocaine and amphetamines.
Like food, for example, is an obvious example, or sexual activities. So these normal behaviors activate in the brain a number of pathways, including the pathway that is associated with dopamine release. And drugs of abuse activate these same pathways, but a major difference is the duration of the activation. Natural rewards will activate these pathways for short periods of time, while the drugs will activate the same pathways for prolonged durations. And this is the unnatural part. And therefore these long activation of the dopamine accumulation in the brain are the ones that will induce these long-term changes in the brain that may lead to addiction. While obviously we're not normally not addicted to food, for example, but we end up being addicted to these drugs, and the major difference is probably the pattern and the duration of activation of the dopamine release in the brain. This is certainly one of the critical mediators of addiction.
You say, what's the difference between cherries and cocaine? Cherries have a lot of different qualities. They are, the pleasure from eating a cherry is fairly short. Okay? These drugs last a long time. And what we're interested in is what do they do to the brain when they last, when you get these long-lasting effects. They're not natural ways of activating the system. So the system is natural, but the drugs are not natural ways of doing it.
These drugs create a new situation where the neurons that would normally release a certain amount of dopamine now release much more. The brain is fooled. It thinks that something really good has happened. The reward pathway is activated in the same way it is when you find food, but stronger and for longer. It is because of this activation of the reward pathway that people can become dependent on drugs. Our brain is programmed to repeat the actions that lead to dopamine release in the reward pathway. This is because the reward pathway is there to encourage us to do the things that we need to do to survive, like eating and searching for sexual partners.
Now, the immediate effects of the drugs on the brain now are pretty well known at this period, but how these drugs end up inducing addiction is a lot more difficult. However, what we know at this point from the research that's been going on throughout the world, actually in many different labs, is that when somebody uses drugs of abuse like cocaine or amphetamine, the brain actually ends up being changed. It's like a long-term memory that's induced in the brain. If we go through in our lives through some traumatic event or something that's very significant for us, maybe the death of somebody in our family or something, an accident or something, but we will remember that for a long time, for the rest of our lives usually. And drugs, in a sense, kind of induce a similar type of long-term change in our brain, some sort of a long-term memory trace, such that once we use drugs like cocaine or amphetamine, a long-term change happens in our brain, actually a structural change. That means the connections between cells in the brain, between neurons, end up being changed for a long period of time. And therefore, once you've experienced the use of these types of drugs, you end up being, it looks like you end up being more susceptible to the effect of these drugs in the future. So when you're re-exposed to the drugs in the future, you can actually be what we call sensitized to the effects of the drug. So that means in comparison to another individual who's never experienced a drug, you might experience a bigger effect, a bigger subjective effect of the drug. So in a sense, this may be one of the mechanisms that induce this cycle of addiction, whereby there's subsequently a compulsive urge to keep on using the drug and seeking the drug.
Well, one thing we know about, let's say, the drug amphetamine. Amphetamine acts on the dopaminergic system, and it causes the dopamine to stay outside the cell for a long time. And through that, it activates other neurotransmitters that are normally activated under slightly toxic conditions. So that process may initiate some kind of repair actions in the brain, trying to make the brain, more stable as a result of all this activation going on. And that may induce long-term changes in the brain that then change the way those neurons function. And that's what people are trying to figure out. What is it that a lot of exposure to these drugs does to change the way the brain acts normally?
Scientists know less about the long-term effects of drugs than they do about the short-term effects. In this experiment, 8 doses of ecstasy were given to monkeys over 2 days. On the left, you can see the normal connections of serotonergic neurons, a certain type of neuron in the brain. Here we see the brains of monkeys 2 weeks after being administered 8 doses of ecstasy. Notice that there are many fewer connections than in the normal brain. On the right, you see the brains of monkeys 7 years after taking the same dose. All drugs cause short-term effects on the brain. Most drugs, when taken excessively, have long-term effects on the brain. This is because the brain is always changing, learning, and adapting to new situations. Hopefully, your brain is changing right now, because you are learning at school. But the brain is also learning and adapting to the effects induced by drugs. Drugs disturb the equilibrium that the brain needs to function normally. So the brain reacts to drugs by modifying its connections. The exact nature and the consequences of these modifications remain, for the most part, unknown. New research continues to enlighten our understanding of the long-term effects of recreational drugs.